All right, we're just gonna do a brief format overview of the auto reverse engineer loop that I've set up here. Um, so how this works is I set up a mission for this guy to do, and there's a auto underscore RE Python script that is kind of like um, his script to stay on this loop that we figured out. The broad strokes of the loop are first he'll check the status, which gives him the mission. And then he'll do static analysis of the code base. He will then, based on that static analysis, do explorations in the debugger. And these explorations are open-ended and not overly prescriptive, so you can basically do whatever he wants. And then from those explorations, he'll produce observation files, and the observation files will then feed into the next stage, which is verify. Verify is a mechanical step, where what he'll do is he'll just like say, hey, this observation said that if you put a breakpoint here, running this save state in this scenario with this input playback running, we'll hit it and it will be from this call site or whatever. Um, and that's actually the verify step is a script itself. He just runs the verify script. So it's purely mechanical. And the point of that is to score the observations to say like, hey, this actually did happen, or it didn't happen. And if you have multiple data points verifying that, then it becomes a higher scored verified observation. And then um, yeah, I'm recording. Sorry. And then from there he will do an integrate step where he'll bring all the information together and try to understand what the code actually does. And he will produce from the integrate step NOP tests. Now, what NOP tests are tests that you do with the human, yourself, the user, where he will start up a save state, start up that scenario that maybe that he just verified, knock out a call or a piece of code, basically remove that code, and then he'll say, "I expect this to happen." Like I expect the the car to no longer render, or maybe the AI drones will stop moving. And then after the knob, you as a human will say, "Actually, this happened," or "No, you're right, this totally did happen." And that he will take that piece of data and plug it back into the system, and it becomes like a bit of ground truth, where it says, "Oh no, we were way off on this. Is actually totally wrong," or "No, we were right." Um, from that point, he also does checks in with a reviewer to catch mistakes, and once he has and then he can start the loop all over again. Uh, the way this works is that he can actually loop and loop and loop and produce a whole bunch of NOP tests. Like, let's say you do this while you're AFK, like that's the whole point. Um, he will then, you can come back to your computer and he'll have like 10 or so NOP tests for you to sit down. You can just burn through them really quickly. And then you say, okay, this is the result of all the NOP tests, and he'll mark all the results down. And then he'll go back at it. He may have to go back in to the auto reverse engineer loop to study some things that got invalidated, or to continue on because now that things are validated, if it was a positive result. So let me just walk through an auto RE loop that I just did in Daytona CCE or CCE. There is a BLK file. I don't really know what it does, and we need to figure out what it's doing because there's functions reading from it during gameplay. We have a hunch that it's related to rendering, but also it's related to gameplay, and we need to make sure all the gameplay code for CCE is detached for this mod to be successful. So we'll start at the top here. Um, we're asking him to do a full decode of this file format. and all the call sites. We actually know there's a couple of call sites that are important because we tried to remove them and it broke the entire game. So let me actually take a look at the mission file. Not that file. Here we go. This is the file. You can see my previous AutoRE loops here. So like mapping the driving model. He says it's complete. It's a little optimistic. We learned quite a bit. We didn't fully complete it though. Um, let's see here. Yeah. So this is where we're on right now. We're on this BLK file. And so in the mission file, this is how like he stays focused. The AutoRE Python script will say, hey, check in with your mission file. Make sure we're still marching towards that goal. Um, let's see here. What did I want to show you guys specifically? Yes. So these are the two. This is what got started. These are the two call sites that we originally removed, and it caused the entire rendering to break. Um, and so there's two things I've asked him to do. One is to map the BLK file, um, and the other thing is like figure out what these calls do. So let's go back. So he's starting to map it. So this is now a little tutorial of the emulator debugger that we have set up here. Um, the Medafin debugger is available to him via an MCP, which is a Claude tool. I like MCPs for this because they surface the different functions that you want to do, like the ones you see on screen, like boot, frame advance, load state, read memory. Um, in a way, they surface these in a way that is simple for Claude to understand. I find that if we try to do this with a skill file, and that the original version of this was actually just skill files with the debugger, and he could do it, but he wouldn't do it very confidently, and he would forget how to do it or kind of constantly be reinventing how to run the emulator. Um, with an MCP, you're basically telling Claude, this is how you run the emulator, no questions asked, never deviate from this. And also, the way the MCP is written, um, it's self-documenting. So you don't have to remind him ever how to use this thing. He will instantly understand how to use this MCP. Um, so let's see what he's doing. He started the emulator. He loaded our race save state, which is at the beginning of 3.7 Speedway. He's looking at the memory. He's looking at where he actually knows already where the BLK file is in memory. And he's doing some analysis. This is what Claude does really well, pattern matching. He's just going to figure this out. He's like making some conclusions. My experience of the conclusions are like usually right, but sometimes we're wrong. This is why I have the AutoRE process. Why it came about, because it helps him, come to better conclusions than normally his like hand waving, like, oh, I know exactly what this is. When this project started, that was the trouble we ran into. He would make outlandish claims about what the code is doing, and it was like half of them were right, half of them were wrong, but the ones that were wrong were so poisonous that you couldn't even tell what was right. So this process was born. So the fact that he's making this claim is totally fine. The process is going to validate this if it's true or not. So let's just let him do his thing for a bit. He's doing more stuff, more dumping registers, figuring out where the program counter is. Oh, look, this call is never called directly. Interesting. Once he feels like he's got enough. How long did this go? This is when I was having breakfast, so I don't know how long this ran. Oh, is this where okay, yeah. So like what he did is he loaded this start. He actually pressed gas a little bit, sampled memory, and then took it off the accelerator. And then he That's right. We have a blob to comma separated values tool, and he found that the pointer is progressing through the BLK data, which is very cool. Um, okay, here's the critical part. He created observations. So here's one of the incremental steps in the AutoRE loop. He'll say explore check for function, and it gives him um, this health marker, like how well his observation is doing. And also tells him like, hey, this is a good place to commit, and move on to the verify step here. Let's see here. Now he's going to run verify. So let's take a look. He's just run the verify command. This will tell him I think this step produced the claim file, and then he's going to run test claim. This is our mechanical test verify step that I mentioned earlier, using the YAML file as input, and it's purely mechanical. And then it'll say pass or fail. Okay. Both passed, so he committed. What's next? Next he does integrate, and integrate just tells him like what's the lay of the land based on everything we've learned so far. And it's a huge mess. It doesn't make any sense to try and read this yourself, but it makes sense to him. This will tell him like, all right, start making NOP experiments. And the NOP experiments are what I mentioned before. Let's see here. So here, before he makes the NOP experiments, he kicks off a review. So he asks a sub agent, and this review text is canned. It's produced by the AutoRE scripts. So there's the agent he kicked off, and now the agent's doing all this stuff. And it caught, agent gave him feedback about how he did, and the reviewer says to keep going. So here, actually, I have to skip ahead a little bit because I found a bug, and I'm always constantly finding bugs in this thing. In the actual process where he doesn't know how to do a NOP test. This is a fresh agent. So we're going to skip past this section where I'm debugging with him. He starts to try to improv a NOP test based on like what he thinks it is. And I'm like, hey, I think you're getting confused. And then blah, blah, blah. We'll skip through all this. Where did yeah, he figured out what a NOP test is, but then he didn't do it right. Okay, so we're past the parts where I debugged the bugs in the auto RE process. Now he's going to produce this NOP test. What he's testing is we're going to skip a function and we're say, does it still render? Do all the AI cars behave? This is what he thinks. He thinks it'll vanish and it'll be skybox only, but we're going to tell him what really happens. So now it's running. Now, this is when I started recording. So we've got the full game here. I'll just pause here because I already know the answer. I played a little bit and I noticed the arcade timer doesn't decrement. The track timer isn't incrementing. All the AI cars are the same, and I've actually already done a lap, and you can see we're still on lap 1. So the behavior that we're actually going to report back to him is that everything's rendering fine. All the AI cars are fine, but this call was actually for decrementing the arcade timer and the lap timer, and also something to do with detecting laps as well. So let's do that right now, actually. Um, so I'm going to ask him to record the results here. Here's all the previous NAP tests I've done before, and we just keep amending. So there's like a perfect history of like everything we've learned from human observation. And as you can see, there's, like it seems like a lot, but there's really not that many in here. And this goes to show kind of the thing that's also really impressive about this. You don't need that many data points for him to draw really interesting conclusions about what the code is doing. You just need to like reveal fog in like these critical points, and like kind of like solving a crossword puzzle, he's able to sort of fill in the rest. Um, all right, let's do this next snap test. See what happens. The debugger normally runs headless, but he does have the ability to show it to me when we do these interactive tests. Don't forget to show the window, buddy. Okay. He thinks the rendering is going to break. All right, let's see here. What happens?
And they're underway.
Ooh, look at this. Okay, let me see if I can.
Turn around, you're heading the wrong way.
Okay, he thinks I'm driving. Oh wow, the game thinks I'm driving backwards also. And we see this. Oh, this is gold. This is solid gold.
7 laps to go.
Okay, there's a lot to articulate here. Oh my gosh. Following the um, timer and lap counter and um, this was a great NOP test. All right, let's see. What did he say? Contract short, track beyond the initial cell visible Jimmy's. Okay, we actually need this data. So let's see here. Alone. Segment streaming. Okay, so this data is essential for rendering. Interesting. All right. Well, with that, I think we should call it in this presentation of the Auto Reverse Engineering Toolkit. Um, like I said, how this flow normally works is you send him down on these paths, and he can loop and loop and loop as far as he can get until you need to, come back from AFK, come back from lunch, and bang through these NOP tests. In which case, he'll get these wonderful like human observations about what's happening in the game, and then he can do the next loop. In my experience, he does these loops fairly quickly. Um, the longest I've ever seen him work on an auto RE loop is like maybe an hour. He's able to come back with knob tests usually pretty quick. So it's pretty cool stuff. Thanks for watching and take it easy.